Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest, minimum operations to form subsequence with target sum. The problem is very interesting. As always, we'll start from scratch. We'll try to build intuition step by step and finally solve the problem. So with that, let's get started. The problem states that you are given a zero indexed array nums consisting of non-negative powers of 2 and an integer target. In one operations, you must apply the following changes to the array. Choose any elements such that nums of I is greater than 1, remove that element and add nums of I by 2 twice to the end of the array. You have to return the minimum number of operations you need to perform so that nums contain a subsequence whose sum is equals to target. If it is impossible to obtain such subsequence, return -1. So let's take an example. Let's say nums is 1, 2, 8 and target is 7. Basically, we need to convert this nums into something such that the subsequence of that array sum can be 7. So for example, in this case, you can see there is no subsequence that can sum up to 7. So 1 plus 2 is 3. If you take 8, the sum will always be greater than equals to 8. So there is no subsequence at all which sums up to 7 in this particular array. So we apply one operation. Let's say we take 8, remove 8 and add back 8 by 2, which is 4 comma 4 twice. So we converted the array to 1 2 4 4, and in this array you can see there is a subsequence which can sum up to 7. 1 plus 2 plus 4 can sum up to 7, right? So in one operations we are able to convert this array into something whose subsequence can be sum up to 7, and hence the answer here is 1. Let's take one more example. 1 32 1 2. Again, this array doesn't contain any subsequence that can sum up to 12. Why? Because if you take 32 in your subsequence, the sum will be greater than equals to 32. So without 32, the sum is 1 plus 1 plus 2, the maximum 4 you can form. So the given array doesn't contain any subsequence that can sum up to 12. So we perform one operation. We convert this 32 to 16 comma 16. Again, this array also doesn't contain any subsequence that can sum up to 12 because of same reason. If you take 16, the sum will be greater than equals to 16. If you don't take 16, the maximum you can have is 4. Finally, let's say you convert this 16 again back to 8 comma 8. So you converted it, added to the end. Now this array contains a subsequence that can be sum up to 12. For example, 1 plus 1 plus 2 plus 8 is actually 12, and hence in two operations you are able to convert the given array into something which contains the subsequence that can be sum up to 12, and therefore the answer here is 2. So hope the problem statement is clear. Now how to solve this? So there are a lot of moving pieces here. First, let's tackle this. So they are saying that add 2 occurrences of nums I by 2 to the end of nums. So does this end actually matters? The answer is no, because finally you want a subsequence, right? You don't want a subarray or something of that sort. So order of element anyways doesn't matter. So it doesn't actually matter if you are adding nums I by 2 to the end of the array or to the beginning of the array or somewhere else. So because of that, we can simply ignore this particular fact, and this entire operation will then become remove any nums of I greater than 1 and add back nums of I by 2, 2 nums of I by 2 to the array. Where you are adding doesn't matter. Secondly, we want the minimum number of operations such that nums contain a subsequence whose sum is equals to target. So given an array, figuring out whether there is a subsequence which can sum up to target or not is itself a good problem to solve, which can be solved using recursion or dynamic programming. So if you haven't solved this, I would encourage you to think about this for a moment. Like, given an array, let's say this is the array, you have to figure out whether there is a subsequence that can be sum up to, let's say, 12, yes or no. So even that problem is a good problem to solve. But apart from this, they are saying that okay, you need to perform some operations, and that too we can perform operations on any element greater than 1. So there are multiple possible branches here, which we may need to explore, and then figure out whether each of the branches can form a subsequence or not. So lot of things, right? So let's first try to start with whether a given array contains a subsequence that can sum up to the given target. So let's say the target is 15 and this is the given array. Now one important thing to note here, again you can solve this with dynamic programming for sure, but as we have discussed, there are other things in the problem as well. This is not the core of the problem, this is just a side problem, which is the core problem is you need to perform some operations on this array and make it a subsequence, and such that the final array has a subsequence that can sum up to target. So the subsequence piece is not the core of the problem, so you can't, applying binary search is not efficient at all. So the second thing we need to observe here is every number here is a power of 2. So whenever you see power of 2, try to think in the direction of binary representation, because that is a hint that something of binary representation is or might be helpful. So let's say we represent this 15 in its binary format. So 15 is 8 plus 4 plus 2 plus 1, which is 15. Now what you can say, everything here is a power of 2. So one of, like, whatever it contains will be one of these powers, right? So there can be 31 distinct element here, right? Because it is given that target nums of i's is equal to 2 to power 30. So there can be 31 distinct element here, and there can be 31 distinct element in target as well. So what you need to do, you need to just make sure that whatever is there here is present here as well, and if it is not present, you need to make it as well. For example, in this case you have 1 8, there is 1 8 already, you have 1 4, you have 1 4 here as well, you have 1 2, 2 is present here as well, and finally you have 1 1, so 1 is present here as well. So all the elements here are present in the given array, so you don't need to perform any operation. The given array already has a subsequence that can sum up to 15, right? Now one important thing to note here is we are able to do this binary thing only because the given array contains only the numbers which is a power of 2. If it doesn't contain power of 2, this matching itself will not yield the correct result. We have to do by dynamic programming kind of solution there as well. So for now, let's say try to simplify this even further. Let's say we prepare a array something like this from the given array. So it contains the frequency of every 2 powers. So it says that 1 is present 3 times in the array, right? Similarly, it says 4 is present 2 times in the array, and so on and so forth. So basically we prepared this frequency array. Now what you can do, or what you have to do, is just make sure that this frequency array and the given target array is a subset of the frequency array. Basically every bit that is set here should be set here as well, right? So that's our motive. So in this case you can see directly that the given array itself, when converting, has every bit set which is set in the target. One more thing to note here is, in this target every position can have either 0 or 1, because you are converting this target into its binary format. So every position can be either 0 or 1, but here the frequency can be greater than 1 as well, based on how many times it occurs, right? So let's take one complex example. Let's say target is 39, right? And from now onwards we will only consider this array, which is just a representation of the given array, right? So let's say this is the given array to us, and we want to we want to assure that can we form 39 or not, right, from this array. So 39's binary representation looks something like this, right? And if you see, we have 2 power 2 here, right? We have 2 power 1 here as well, we have 2 power 0 here as well, but 2 power 5 is absent, so this is not directly matching. Now you need to make 2 power 5 here, right? So you have two choices. Either you convert a greater element to smaller element, basically we have been given, right, nums of I can be converted to nums of I by 2. So either you convert a greater element to the smaller element by doing some operations, right, or you know that there are some remaining elements as well, right? So you just have consumed 1 to power 2, so there is 1 to power 1 left. Similarly, there is 1 to power 1 which is left, and similarly there are 2 to power zeros which are left. So there are some leftover numbers as well. So what you can do as the second choice is, can I make 2 power 5 from this leftover numbers or not, right? So these are the two possible choices that you have. Which one will you try first? The answer is always the second choice. Why? Because first choice will incur you some operations or will incur you some cost, but second choice is free of cost. Basically you are just reusing the elements that is present in the array, so you are not incurring any cost. So we will always try with the second choice. So we will always say, can we make the non present element from the given set of element or not, right? So in this case we have 1 2 left, 1 to power 2 left, 1 to power 1 left, and 2 to power 0 left, because they have one of them is used to satisfy the given powers. Now we have these all things left. Can we make 32 from these all things? So that is the new problem. So in general, let's say we have this array, we have 2 to power 2 left, and we have 4 to power 0 left. And if you think 4 into 3 12, 1 into 4 4, so we have in total 16 sum, or 16 is the maximum sum you can form from the remaining element. So can you make everything between 1 and 16 from this numbers? The answer is no. Why? Because you will, like, okay, so the thing is you may be able to make everything between 1 and 16. That is something we don't want to solve. We are only interested in the fact that whether 2 power 3 or 2 power 4 can be possible or not. So in other words, what problem we need to solve is, can we make every 2 power x where x is greater than equals to 3, or x is greater than greater than equals to 3. So basically, can we from these all remaining elements, if the sum is greater than equals to 8, can we make 8? If the sum is greater than equals to 16, can we make 16? If the answer is yes, then what we can simply do is we can simply sum up all the remaining elements that we have, and if the current element that we are trying to satisfy, if it is less than the sum of the remaining elements, we can simply say we can make the remaining elements from the given set of elements itself. So let's take one example to understand this bit more. So let's say you want to make 16 out of this 304, right? So you have this 304. So what you can say is, okay, I will convert 2 to power 0 to 1 to power 2 to power 1. So basically what we are saying is 2 power 0 plus 2 power 0 is equals to 2 power 1. So what I can do, I can simply take 2 to power zeros and convert it to 1 to power 1, and I will get something like this, 312. I will do the same operations again. I will convert 2 to power 0 here to 1 to power 1. So again this will become 0 and 1 will be added here. So this is the final state. Now in the same fashion you can convert 2 to power 1 to 1 to power 2 as well, right? So you can convert this to this, correct? And finally you can convert this to 2 to power 3 as well. Basically in one step you can convert 2 to power 2 to 1 to power 3, and in another step you can convert 2 to power 3 to 2 to power 2 to power 2 to power 3 as well. So once you have this, again you can apply the same operation. You can convert, you have 2 power 3 plus 2 power 3, you can simply convert this 2 power 3 to 2 power 4, right? So finally you get 2 power 4 which you wanted. So basically what we saw just now is, if we have sum less than equal greater than equals to 16, we should be able to make 16 without any difficulty, right? Now is this always true? Let's try to prove it. So the answer is yes, it is always true. We should be able to make all 2 power x where x is greater than equals to 3. And how? Think about this. So let's say you want to make 2 power 3, right? If you want to make 2 power 3, what all ways you can make 2 power 3? So you want to make 1 0 0 0. So we are applying the reverse operation now. We are saying that okay, we want this configuration. So this configuration is equals to this configuration. Why? We can simply say that okay, I've converted this 1 to power 3 back to 2 to power 2. So I've converted this 8 to 4 plus 4. So that's what we have done. So we converted this to 2 to power 2. Similarly you can say I have converted this 1 to power 2 remains, and I converted 1 to power 2 to 2 to power 1. In same fashion you can say I have converted this 1 to power 1 here to 2 to power 0, and so on and so forth, right? So what you can see, there is a configuration that has 0 to power 0, there is a configuration that has 0 to power 1, and there is a configuration where there is 0 to power 2 as well. So basically any possible configuration of these three elements, if they sum up to 8, I should be able to make 8. That's what this thing proves. Basically you can see it doesn't matter whether all the numbers are present or not, whether 2 power 2 to power 1 to power 0 is present or not. What matters is whether the sum of everything is greater than equals to 8 or not. If it is, I will be able to make it, right? In the very same fashion you can argue for 2 power 4 as well, or 16 as well. So you can say you can just expand this in a very similar fashion. You will see there are configuration in which some element doesn't exist. For example, there are configuration in which these three doesn't exist, only 2 power 0 exist. And if there are enough 2 power 0 to make 2 power to sum up to 16, you should be able to convert this 2 power 0 to 16 without any difficulty in the process that we just saw a while ago. So hope this intuition makes sense. Basically what we are saying is, if the sum is greater than equals to 2 power x, I should be able to make 2 power x. That is something we have just seen. So in this particular scenario we saw that we like, if you remember, we discussed that there are two choices: either we make some operations and convert the greater number to smaller numbers, or we combine the remaining elements to see if they are able to make or satisfy the current requirement. So in this case the remaining element sum, if you find out, it is 2, it is 2, it is 4, it is 8, and it is 16. If you just sum them all up, they come exactly as 32. And because the remaining element sum is greater than equal to 32, what we just saw is we should be able to convert these elements to 32 without any difficulty, right? And because of that we can simply say that with remaining element I will be able to satisfy 32, and hence I will just satisfy 32 from the remaining elements and be done with it. like we don't need to do any operations here. So in 0 operation we are able to convert this array to something which contain 39, which contain a subsequence that can sum up to 39, right? So if it doesn't make sense, I would encourage you to pause and rewind the video and watch that particular section again. I am very sure you will be able to get it. Now let's take one final example where its target is 47. So in this case you will see the same thing. We have 2 power 3, 2 power 2, 2 power 1, 2 power 0 in the given array as well, but 2 power 5 is not there. But the only difference from the previous problem is here we will not be able to make 2 power 5 from the remaining elements. If you see, number of remaining 2 power 0 is 2, number of remaining 2 power 1 is 1, number of remaining 2 power 2 is 1, and number of remaining 2 power 3 is 0, right? So if you just sum them all up, it will be 2 plus 2 plus 2 plus 4, which is 8, and 8 is less than equals to 32. So you can't make 32 from the remaining elements. And in this case, you have to apply operations. Now, applying operation can be done in two ways. Either you will convert this 2 power 7, or there are two things, right? There are two numbers which are greater than 32, 64, 128. So either you can convert this 64 to 32 and 32, right? This is one choice. Or you can convert this 128, which is 2 power 7, into 64 and 64, right? So these are the two choices that you have. Which one you will choose? So I would encourage you to pause and try to think about yourself which of these two choices are optimal. To understand which of these two choices are optimal, let's first understand what is the power of a single operation. So let's say you want to break 2 power 6, right? So currently this is the configuration, you want to break 2 power 6. Now we have discussed previously as well, we can convert this 2 power 6 to 2 power 5 without an issue, right? Basically 2 power 5 plus 2 power 5 is equal to 2 power 6, so we can convert this 1 2 power 6 to 2 power 5, right? In the same fashion, we can say, okay, I will keep 1 2 power 5 with me and I will convert the remaining 2 power 5 to 2 power 4, right? And in the same fashion, I can move forward and get this configuration, and so on and so forth. If you keep on doing this, you will finally land on something like this. So with just 1 2 power 6, you are able to set everything in the right. And if you remember, we discussed previously that in the target, the frequency will be either 0 or 1, because we just converted this number to binary format, so the frequency would be either 0 or 1. And with this 1 2 power 6, we are able to make everything as 1. So basically we are saying that with just 1 2 power 6, we should be able to satisfy any requirement which is less than 2 power 6, right? Why this happens? This happens because of a very interesting property, that 2 power x is always greater than summation of 2 power I, where I ranges between 0 and x minus 1. So basically if you sum them all up, even if you sum them all up with 1 1 1 1 1, the value would be less than 2 power 6, and in fact the value would be exactly 1 greater. So this will be equals to this plus 1, right? So because of this property, you are able to achieve this configuration. So what this means is, with just 1 2 power 6, you should be able to satisfy any requirement that you may have in the right. Now tell me, which one will you pick, 2 power 7 or 2 power 6 for your operation? The answer is now simple. You will always pick 2 power 6, because if you pick 2 power 7, you have to do one operation to convert it to 2 power 6, right? So if you pick 128, you have to do one operation to first convert it to 64, and then from 64 you will be able to convert it to something less, right? So you are wasting one operation here. So why you will want to waste one operation? Because you want minimum number of operations, so you don't want to waste any operation. So that's where we will always pick the one which is nearest to us in the left, right? So in this particular case, we want 2 power 5. We just traversed to the left, we saw the first set number which is 2 power 6, we pick that and we say that it is now 0, and I am able to satisfy, I will just make it 2 by making it 0. So basically sorry, so basically we are just converting the given number into one of these formats based on which one you want. So let's say you want 2 power 3, let's say there were no 2 power 3, you want 2 power 3. In that case you will keep on applying until you hit non-zero value at 2 power 3, right? So you will do 3 operation in this case. But if in this particular scenario we want the non-zero value at 2 power 5, so we just do one operation, and in one operation we get non-zero value at 2 power 5. So in one operation we are able to convert the given array into the, or we are able to convert the given array into something which contain a subsequence that sum up to the target, right? So hope this entire solution makes sense. If you have any doubts in any of the piece, I am very sure if you rewind the video you will be able to get everything. All the timestamps I will put in the description below so that you can move back and forth as you like. So what is the complete solution now? Complete solution is you will keep on matching the numbers, right? If there is a bit which is set in the target but is not present in the given number, you will first see what all things are remaining, or how many what is the sum of the remaining numbers that you have in the left. If the sum is greater than the current value, then you should be able to make that number. So you will just make that number from the sum and move forward. So let's say the sum is 35, just an example. Let's say the remaining sum is 35 and you want to make 32. So you are sure that with 35 you should be able to make 32. So you will just subtract 32 from here. You will say, okay, now the remaining sum is 3 and I assume that I have made 32 somehow, and I will move forward, right? If you are not able to make, or if your remaining sum is not greater than equal to 32, for example, let's say the sum is 31. So 31 is not greater than equal to 32, so you can't make 32 from 31. Then you will simply find out the first non-zero element in the left and keep on applying the operation until you hit the current number. So you just keep on applying the operation until you hit the current number, which is this possible configuration. And once you hit that, you can simply apply the same approach. You want 1 to power 5, let's say you want 2 power 5, so you want 1 to power 5, you will just subtract 1 to power 5, and whatever is remaining you will add back to your remainder. So this is now the new remainder that you have, right? So hope you will just keep on doing this and you will get the many number of operations at the end. So one last thing before we close this off, some of you might be thinking that, okay, what if we want 2 power 5? This is the same example, so you will not be able to make the 2 power 5 from the remainder. So you want 1 to power 5, but the nearest element that you have the set bit is also set in target. So will you take 2 power 6 or will you take 2 power 7? I would strongly encourage you to pause and try to think at least for 5 minutes by yourself. So the answer is, it doesn't matter. You can take any. You can either take 2 power 7 in this case by assuming that 2 power 6 is 0, or you can take 2 power 6 and make it 0 and then convert 2 power 7 to 2 power 6. Both will yield the exact same operation. How? If you think about it, you need to convert, let's say you need to convert this to 2 power 4, just an example, right? This is the target, so you need to convert this to 2 power 4. So if you convert 2 power 6 to 2 power 4, you require 2 operation here, right? If you convert 2 power 7 to 2 power 4, you require 3 operation here, right? So if you say that, okay, I will keep 2 power 6 as it is without, because it is present in the original array as well, you can simply say that I require 3 operation to convert this 2 power 7 to 2 power 4. And in other scenario where you actually convert 2 power 6 to 2 power 4, you require 2 operation here, and in that case you made 2 power 6 to 0, right? Now you want 2 power 6 as well, so you can simply convert 2 power 7 to 2 power 6 in one operation. So here as well you require 3 operation, and in that other scenario as well you require 3 operation. So that's why it doesn't matter which operation you apply in this particular scenario. So for simplicity, you can just stick to the fact that I will just find the first nearest element which is set and I will convert it. So that will make the solution a bit, or implementation a bit more simple. But as discussed, we don't need to, you can implement the other solution as well, which should be fine or give you the minimum operation as well. So next we're looking at the code. I am not showing you pseudocode. Pseudocode is exactly straightforward. We just need to do exact same operation. We just keep on matching when something doesn't match, or in other words, when a bit is set in the target but not in the given number. We will look at the carry. If carry is small, we look at the we look at applying some operation. If the carry is greater, we will not apply any operation and move forward. So I would strongly encourage you to pause and try to code this entire thing by yourself and get it submitted as well, because that's what is important. So next we're looking at the code. The code is straightforward. As we discussed, we convert this everything to power, to this frequency array count. So this is, if you remember, at the very beginning we have done that. We have converted this given array to this frequency array. So that's what we are doing here. Once we have this count array with us, we then have two things, carry and result. Result contains the number of operations you are doing, and carry contains the number of remaining elements that you haven't used in the left or in the right, depending on how you look at. So we just keep on applying the operations from smallest to the largest, right? And whenever a bit is set, a bit is not set in the target, let's say this one, you can simply add the corresponding, let's say a bit is not set in the target, for example 2 power 6, just example, and it is set in here. So you can simply add this to your remainder. So that's what we have done. If it is not set, we'll just simply add it to our carry. If it is set, then couple of things can happen. Either, let's say this bit, we are talking about this bit now. So if this bit is set here, either it can be set here as well, in which case you can simply reduce its frequency and add remaining thing to your carry and continue. Or it may happen that it doesn't set here, this particular scenario. It may happen that it doesn't set here. In that case, you will see if carry is able to compensate for that. And as we discussed, if it is able to compensate, we should be able to make 2 power x for sure, without any issues. So if carry is able to compensate, we will just compensate with carry and continue. Otherwise, we have to do operation. And as discussed, we will pick the first non-zero element in the left or the right, how you look at. So we start from i+1, or in other words, we start from the next element and see what is the first non-zero element. So this is this particular scenario. We wanted 2 power 5, but the remainder is not sufficient to make 2 power 5. So we start from the left, we start from 2 power 6 and see what is the first first non-zero element. So once we found the first non-zero element, we'll simply keep on applying these operations. What is the operation? Remove this, remove one element here, add 2 here, right? Similarly, remove one element here, add 2 here, remove one element here, add 2 here. You will keep on doing this until the number or the index you want is non-zero. So we wanted ith index to be non-zero, so we keep on applying this until the index is non-zero, and every time you apply this, you have to increment one operation as well. And finally, you'll see if you don't have any non-zero element in the right or in the left, you will simply return -1. If there exists a non-zero element, you actually have done these things. So now the ith element is for sure non-zero. So in that case, either you can, like, let's say you get 2 here. So there are two choices. Either you simply remove this 2 and make it 1 because you want 1 here, and just add the contribution of 1 to the remainder. Either you do it directly here, or you can say, okay, I will just redo the work for this index. So that just simplifies a bit of implementation. So I will just do I -, and when this loop again executes, I will then hit this condition and I will continue, right? So hope this entire solution makes sense. What is the time complexity? Time complexity is simply 2 for loop, 1 which runs over the bits, second which also runs over the bit. So this entire time complexity is just order bits square. You can convert this time complexity to order bits into bits log n as well. So you can convert it into bit into log of bit as well if you want, and that can be a exercise for you using segment tree. If you don't know segment tree is something we have started recently in our channel. We have a lot of videos on segment trees now, starting from scratch. So if you don't know segment tree, you can learn that and then try to implement or optimize this by yourself. So with that, I hope you enjoy the solution. If you find it helpful, please share it with your friends so that they can also get benefited as well. And with that, I will see you in the next one. Thank you.